This is Mr. Precella in my trigonometry class, and today we're going to be looking at some applications of radian measures. The last time we defined what 1 radian was, and we made the big connection that pi radians was 180 degrees. And today we're going to look at applications, in particular one major application, the arc length formula. Okay? If we have a circle, arc length, we have a circle of radius r, radius r. If we want to calculate the length of the arc that angle is cutting off, arc length, we mean this distance here on the circle. We want to calculate that, then we're going to call this S, and let's call this angle theta in radians. Then S equals R, the radius of the circle, times theta, and this is where theta is in radians. Theta is in radians. Now, I've printed out some problems to work as examples. Let me see. Arc length S equals R theta. In the first one, we have a circle that's radius 12 units, whatever they are, inches, centimeters, I'm not sure. And then the angle here, 7 pi over 4. So what we're trying to find is this distance here. That pink distance we're calling S. S equals R times theta. The radius is 12. Theta is 7 pi over 4. That's going to reduce to what? 4 goes into 12. 3 times 7, 21 pi. So pretty easy, provided you've got to make sure that angle is in terms of radians. If it's in terms of degrees, you're going to have to convert it to radians. Now, what about number 2? Find the radius of the circle. Oh, on this one, we're told the arc length, okay, it's 14 pi. We're told to find the radius r. So S is equal to R times theta. S is 14 pi. R we don't know. And theta is pi over 3. Well, to solve this for r, to get the r completely by itself, I guess the fastest way to do it would be to multiply both sides by 3 over pi. I multiply both sides by 3 over pi. What's happening over here? The 3's and the pi's cancel. Oops. So we have R. And over here, you could think of that as 14 pi over 1. And cross cancel the pi's. So 3 times 14 would be 30 plus 12. Is that a 42? Okay. So 42 units, whatever those are. So we used this formula. We found S on number 1. We found R on number 2. The only thing left to do is to find theta. And that's what we're doing here. On this one, we're told the arc length is 5. That radius is 2. So S equals R times theta. Oh, let me move that up. S is, can y'all tell the difference between my S and my 5? Arc length is 5. R is 2 times theta. Divide both sides by 2. And so you can write either 5/2 or 2.5. I'll write 2.5. If you want to write 5/2, it's going to take either one. Oh, wee. Four is very much like number 3. Number 5, they give you the r and the theta, so S equals r times theta, 16.6 times 3 pi over 4. And we're going to get a decimal number here and round to one place. So this is one of those where I'm going to get my calculator and the glare will be bad and it'll be hard to see. Let's see. 16.6 times 3 second pi over 4. 39.1128. So how are we told to round this? One decimal place. So 39.1. Now, number 6 is very much the same type of problem. How long is an arc? We're told the radius is 3.04 centimeters. Then we're told, ooh, they cut the lights off. I want to get out of here. 45 degrees. Well, S equals R times theta. Here's what I'm going to do. I'm just going to write 45 degrees and do the conversion right here. To convert this to radians, you'd multiply by pi over 180 degrees. That was something we were doing in the previous homework assignment, my previous lecture. The degrees would cancel. That's how I remember that the 180 degrees goes on the bottom. So 3.08 times 45 times pi divided by 180. 3.08 times 45 times pi divided by 180. Now, if you already have memorized that 45 degrees is pi over 4, you could have just used that. 2.41902, how are we told to round? To the nearest hundredth. 2.42. Number 7. Same type of problem, but you're given in terms of degrees, so we're going to have to convert that to radians by multiplying by pi over 180 like we did here. It's S equals R, 17.5, times theta times pi over 180 degrees. 17.5 times 172 times pi divided by 180. I'm punching that into my calculator. And we're getting a 52.5344. 52.5344. Oh, it's up here they tell us how. To 3 significant figures. That means starting here, count 1, 2, 3. That's 52.5. Okay. So to count those significant figures, you just start with 5, count left to right, 1, 2, 3. Now, starting with number 8, we have a little bit of, I guess, a geography problem. So this is number 8. I'm sort of just flying through some examples using this arc length arc length formula. Number 8. 2 cities have the same north-south line of 106 degrees west. The latitude of the first city is 20 degrees north. So, maybe I have room to do it right here. I'm going to draw a circle. This is the Earth. When you're told that the latitude of the first city is 20 degrees north, that means it's 20 degrees north of the equator. So there's the first city. This angle right here, 20 degrees. It's sort of hard to see. The latitude of the second city is 40 degrees north. That means 40 degrees north of the equator. This is the second city. Approximate the distance between the 2 cities if the average radius of the Earth is 6,400 kilometers. So we want to know this distance right there. And so I need to maybe draw this thing bigger so you can see it better. Draw a bigger Earth. There. We're trying to find this distance right here. Note this is very small, but to get this distance right here, or this angle, it would be this angle right there. So the red line, it was up to 40 degrees minus 20 degrees. This angle here is 20 degrees. And the radius is 6,400. And we're trying to approximate that arc length. We're trying to find that distance between the 2 cities. The way we do that, S equals R times theta. R is 6,400. Now theta is 20 degrees, but wait a minute. It needs to be in terms of radians. So we multiply by pi over 180 degrees. That way we can cancel out the little degree marks. And what am I going to punch into my calculator? Well, 6,400 times 20 times pi over 180. Let's see. Oh, let me clear out all of that. Let's see. Can I make it brighter? Does that just increase the glare? 6,400 times 20 times pi over 180, 2,234.02. Let's see. I'll just continue. 2234.02144. How are we told to round this? Round to the nearest integer. So 2,234 kilometers apart. Notice, the way both of these cities were north of the equator, to get that angle in between them, we subtracted the angle measure. Now, here is number 9. Same type of problem. Let's see, do I need to zoom in a little more? Make it easier to read? Do I need to focus it at all? Or is it as focused as it can get? Okay. Here we have the same type of problem, except one city is 17 degrees north of the equator. That's the north city, 17 degrees. That's city A, I should say A. And city B is south of the equator, 45 degrees south. So to get this distance here, you're not going to subtract those two angles. What are we going to do? We're going to have to add them. So here's number 9. Not that the number is that significant. I'm going to draw this circle. This angle here we would get by adding the 17 and the 45, so that would be 62 degrees. And the radius is still 6,400 kilometers. So we're looking for this distance here. That's S equals R theta. S is 6,400 times 62 degrees times pi over 180 degrees. Oh, they cut the lights off again. I can't believe this. Oh, maybe they're not going to come back on. Let me see. There. So I'm now going to plug this into my calculator. 6,400 times 62 times second pi divided by 180. Right here. 6,400 times 62 times pi over 180. 6925.466 dot dot dot. How are we told to round to the nearest integer? So 69, how would y'all round that? 6925. Okay? So those two cities are 6,925 kilometers apart. Number 10. Number 10. Let me do this. Try to cover up those pictures of what's coming ahead. Okay, so here we are. Number 10. Two cities are 1,100 kilometers apart and lie on the same north-south line. So one's just directly north of the other. The latitude of the northernmost city is 47 degrees. What is the latitude of the other city? So here's my Earth. Okay, there's the equator. There's the center of the Earth. Okay, the latitude of the northernmost city is 47 degrees. Okay, so 47 degrees from here to here. What is the latitude of the other city? You see, we have a northern city and we have a southern city. And I'll just make it black. Southern city. Well, we know this distance right here. That arc length is 1,100. Ooh. That's S stands for Southern City. Okay? Maybe I should have used A and B. I don't want y'all to get this S confused with the arc length. This arc length is 1100. So what we can do, knowing that the radius here is 6400, let's go ahead and find this angle theta. Once I know theta, then to find the latitude of the southern city, that would be this angle here. We'll subtract theta from 47 degrees. So I'm going to find theta and subtract it from 47 degrees. Well, S equals R times theta. S is 1100. R is 6400 times theta. So divide both sides by 6400, and we get theta is 1100 over 6400, which I'm going to go ahead and reduce down to just 11 over 64. But wait a minute, that's radians. So we need degrees. So what are we going to multiply by to get this in terms of degrees? Let's see. And I want a degree measurement. That means I need a little degree circle on top. So am I going to multiply by pi over 180 degrees, or the other way around? The other way around. That'll put the little degree mark up on top. So I'm going to punch in 11 over 64 times 180 divided by pi. You better be careful. Put this 11 over 64. I'm going to put the stuff in parentheses. I want this fraction, 11 over 64, times this fraction, 180 divided by pi. So is that, did I punch in what I'm doing there? 11 over 64 times 180 divided by pi. So this would be 9.847 ... degrees. We want to round to the nearest integer. So this 9.8, I'm going to round to 10 degrees. So that means this angle here is 10 degrees. The whole thing from the equator up to the purple line is 47 degrees, which means the equator up to this southern city line would be 47 degrees minus 10 degrees, or 37 degrees. If this were 40, the northern city is at 47 degrees north, the southern city would have to be at 37 degrees north in order for the angle between them to be 10 degrees. Okay? So 37 degrees. How are we doing on time? Now, let's look at, now 11 and 12 have regenerated. They're so similar. I'm just going to do 11. I think the only difference, the way mine have regenerated, is angle measurement and that size. So you're doing the same way. So here's number 11. And then there's one on the next page like this. Okay, I like these gear problems. Two gears are adjusted so that the smaller gear drives the larger one, as shown in the figure. If the smaller gear rotates through an angle of 300 degrees, through how many degrees will the larger gear rotate? Well, the key to doing these is to realize that the arc lengths on each of these are going to be the same. Okay, the arc lengths are going to be the same. So on this one, if it's rotating 300 degrees, whatever this arc length is, it's going to be the same over here. Okay? So the arc length over here equals the arc length over here. So on the smaller circle, we have 300 degrees and a radius of 3.5. So S equals R times theta, that would be 300 degrees, times pi over 180. Let's calculate the arc length on the larger circle now. It's still going to be R 7.1 times theta. Now, what was the angle measurement here? Oh, we don't know what that other one is. Okay? How many degrees will the large one? So theta, but we still have to convert to, theta is going to be degree measurement. So we need to convert to radians. So these two things are equal to one another. The smaller arc length has to equal the larger arc length. So to solve this, it's not really as bad as you think, because right off you could divide both sides by pi over 180. And if you do that, the pi over 180 degrees is gone. We have 3.5 times 300 equals 7.1 times theta. Divide both sides by 7.1. And what we get here is going to be a degree measurement. 3.5, oh, let me clear up. 3.5 times 300 divided by 7.1. 3.5 times 300 divided by 7.1. Theta is 147.8873 ... We're told to round to the nearest integer. So that 147, I would round to 148, wouldn't I? Okay. Any questions there? The key to working with these gear problems is to realize the arc length has to be equal. Whatever this distance is, as this thing's spinning over here, it's going through that same distance. See, I've printed out 13 problems to work. Number 12 is just like that one. So we have time to do just one more. We have a whole page to do it on. This is the same type of problem. The rotation of the smaller wheel in the figure causes the larger wheel to rotate. Find the radius of the larger wheel if the smaller wheel rotates 80 degrees when the larger wheel rotates 50. Well, it's that same general setup. The arc lengths are equal. Arc lengths are equal. So let's find the arc length of the smaller wheel. It would be, that's going to equal the arc length of the larger wheel. So I'm doing R times theta on these. On the smaller wheel, R is 11.1. Theta is 80 degrees times pi over 180 degrees. R, we don't know. So what about theta? On the larger, the angle is 50 degrees times pi over 180 degrees. Can we drop those pi over 180 degrees right off? Yeah, of course we can. Divide both sides by pi over 180, or multiply both sides by 180 degrees over pi. Either way, this and that are gone, because this is an equation. So all we need to do to get the r by itself is divide both sides by 50. So we have 11.1 times 80 all over 50. Am I using my invisible ink, or can y'all tell what? That gets the r by itself. So, let me see. 11.1 times 80 divided by 50 equals 17.76. Let me do it in a color you can see. 17.76. We're told to round to the nearest tenth, so what would that be? 17.8. So the radius of this larger wheel is 17.8. So this is using the arc length formula and calculating arc length, and we're about out of time here. So work on these problems. If you're going to be successful in this course, you've got to stay caught up on what we're doing here. Don't let it build up or anything. And that's my words of advice. We're out of time, so stay warm if it's cold when you're watching this.